We're going to look at a Hooke's Law question today. And Hooke's Law tells us about how forces are related to the stretchiness of springs, or the spring constant, and the distance that they stretch. So in this problem, it says if a mass of 0.55 kilograms is attached to a vertical spring that stretches the spring 36 centimeters from its original equilibrium position, what is the spring constant? All right, so first of all, we're going to need to see our formulas. You cannot do these problems without formulas, so let's take a quick look and see if we can't find a formula that looks good for us. And it says the elastic force is equal to negative kx. Right, so there's our formula. So let's define what these are. The force is going to be in newtons. K is our spring constant, and x is the distance that it stretches. So going back to our screen, let's go ahead and, as always, start out by writing down what we know. So we're going to write down what we know here. We know that the mass is equal to 0.55 kilograms. And we know that the spring stretches a distance of 36 centimeters from its original equilibrium position. And we know that we want to find K. Now remember, our formula says that force, elastic, is equal to negative kx. Do we have what we need to solve this problem yet? We don't have a force here. We have a mass. But we can remember back to Newton's second law that says force is equal to mass times acceleration. What's the acceleration in this particular case? That's right, it's 9.81 meters per second squared. We're assuming that this spring is on the earth, and that's our acceleration due to gravity. All right, so let's take our mass of 0.5 times 9.81. Put that in the old trusty calculator here. So we've got 0.55 times 9.81. All right, so 5.3955. We don't need to have all of those decimal places, so let's just carry this out while we're calculating to 5.396. All right, so this is newtons. This is a force. So now we can use that to solve our problem. We know the force. We're looking for K. And we know X. How are we going to rearrange this formula in order to solve for K? We're going to divide both sides by X. And we divide both sides by negative x, then we're going to get rid of that negative, and we're going to get rid of the x. And so K is equal to force divided by negative x. Now this looks like we're going to get a negative number, but we need to pay attention to something in particular. What direction is this spring stretching? It's stretching in a downward direction because it says it's vertical. And so this x is actually negative. And so when we have the negative 36 times the negative, then we're going to end up with a positive. We also need to pay attention to something else here with the x. This is in centimeters. We don't want to work in centimeters. We need to convert this to meters. And in order to convert centimeters to meters, we're going to divide by 100. And then we're going to get negative 0.36 meters. So now we can put in our numbers. We've calculated this as our x value. We've calculated our force as 5.396, and now we can substitute and solve. So we've got 5.396 newtons divided by negative 0.36 meters. divided by, I'm not going to put the negative in because I know that's going to end up being positive. And it gives us an answer of 14.9875. We only have two significant figures in our problem, so we can only have two significant figures. So you can see that this is going to round to 15. We look at the third significant figure here, and it's a 9 greater than 5, so we're going to round up to 15. So our answer here is approximately pretty close to 15 Newton per meter, and that is our spring constant for this particular spring.